Outside of Atlanta, about a 500,000 square foot facility, and all we build in that facility are refrigeration systems, refrigeration and power systems. It's a flexible floor plan, got a lot of manufacturing efficiency and flexibility and scalability. Look forward to the opportunity to host you for a visit perhaps. We have a variety of different products. We have very small platform products or catalog products, the smallest of which is the CO2 1 condensing unit, little split system, small little compressor condenser box with capacities anywhere from a 0.5 ton to 2.5 tons. And you can add 1 or 2 evaporators to it and a control panel to it for very small applications that would require CO2. As we step up from that, we have what we call our Flex platform, also a catalog platform product. And you can see the low temp and medium temp compressor ranges of our Flex and mid-effect Flex product line. They come either without an enclosure for indoor applications, or we can provide it with an outdoor enclosure. As we step up in most of the applications of industrial refrigeration, it's an engineered to order rack type system where the customer would provide to us the loads for either like freezer, cooler, dock, duty, and then we would take those loads and engineer a refrigeration system, providing the necessary compressors of low temp, medium temp, vessels, controls, everything associated and tailored to that particular application. The systems are built with a variety of different compressor options and occasionally some different control options, but that's the majority of what we see. We pressure test every one of the transcritical systems that we manufacture. We do have a zero leak initiative program. Every brazier or welder that would weld or braze a joint has a time clock number that is put on that joint. So when it goes into the test chamber, if by chance any particular connection wouldn't hold, it's accountable back to an individual. We have a very rigorous training program for proper brazing and welding. The racks are fully UL compliant both electrically and mechanically. We often would take a rack like that and put it inside, install it inside of one of our outdoor enclosures. The pictures on the left and bottom are what we call a mechanical center. So it allows for walking into that box and walking all the way around the rack. You're out of the weather completely. And it has ventilation, continuous, as well as emergency ventilation for either temperature or even like a CO2 leak perhaps. It comes with typically single point power for the rack and the enclosure itself, as well as operating the gas cooler that it might be connected to. We also offer a little lower expensive, less expensive paratemp type, and that would have doors all around the perimeter that allow for access from the outside of that unit. So Hill Phoenix has been dabbling in providing CO2 systems since 2006. We started off with the secondary fluid or using CO2 as a volatile brine, where some refrigerant is going to be cooling down that brine through a heat exchanger, and then that CO2 brine or volatile CO2 liquid is then fed out to the evaporators. It minimizes the charge of the refrigerant in the rack type system. And we did that for a couple years, and then we started adding compressors to it, so CO2 cascade, that's what we see in the orange. So that would put compressors on the CO2 side of that two-loop system. In 2011, late 2011, early 2012, we purchased a Danish company by the name of Advancer, and they're a European leader of CO2. And Advancer, since 2006, was building transcritical booster type CO2 systems. That opened the door for Hill Phoenix to be able to bring transcritical CO2 into the United States. And in 2013, 2014, what we had is some of our core customers that we serve tried it. And they tried it, they liked it, they realized, hey, now we can get off the hamster wheel of the refrigerant of the month club and go with a natural refrigerant and not be subject to the changes in refrigerant that they've experienced over the last 30 years. And then you can see that after that early adoption, Transcritical refrigeration or booster basically took off. And it's not a fad, it's here to stay. It's one single working fluid, and that's what everybody demands at this point. 2,000 installations in North America, 18,000 systems globally. If you come into our factory, what would you see is about half of everything we build today is CO2 refrigeration. So the simple refrigeration cycle of CO2, basically low temp evaporators that are drawing liquid, vaporizing it. That vapor is going to be cooled and then fed into low temp compressors. You got medium temp evaporators doing the same thing, evaporating into a suction side for the medium temp compressors. Low temp discharge fed into that medium temp suction, discharge up to a gas cooler, otherwise known as a condenser, depending on what your ambient conditions and operating conditions are. And then condensed are fed back down and out of that heat exchanger through a high pressure control valve to the receiver. The receiver then feeds out the liquid to the users of the evaporators to complete the cycle. Very simple two-stage system, very similar to an ammonia two-stage system, but it's got CO2 in it rather than ammonia. So people often ask, well, what is the efficiency of a CO2 system? Well, in that, Hillphoenix has a long history of providing synthetic refrigerant systems. Oak Ridge National Labs actually came in and put together a side-by-side performance operation of the two systems with 404 and CO2. And what they found is that with the air-cooled condensing, ambient temperatures of about 90 degrees Fahrenheit, they're comparable in energy efficiency. But as ambient temperature drops, what we're seeing is a pretty significant increase in efficiency of the CO2 system over the 404. Now, if you did a search on Oak Ridge National Lab CO2 energy efficiency, you'll get a full tech paper from them and see this chart in it. But a lot of that is attributable to the two-stage system that we had showed on the previous slide with low temp compressors and medium temp compressors. A lot of synthetic refrigerant systems use one compressor in full lift from minus 20, minus 30, all the way up to condensing. And we know even with the ammonia refrigeration on a single lift, it's not as energy efficient as a two-stage system. So it's the same that we benefit from in the two stages of a CO2 booster system. So one of the things that we often look at in a Moliere diagram, a pressure enthalpy diagram, is different operation above and below the transcritical line. So often referred to as transcritical. You actually are operating either in subcritical conditions where you're condensing or in supercritical conditions where actually that gas cooler is not condensing to a liquid, but it's cooling down the fluid or the discharge gas from the high temp compressors. So you see operation below and above. Now, don't freak out. You can stand next to the system. If it transitions from subcritical to supercritical, you don't know the difference. It's just operating and maintaining through the controls that are controlling the system. It's not going to operate as efficiently as in supercritical as subcritical, but it's not all lost. It'll maintain its operation through both cycles easily. As I look back on the introduction of CO2 refrigeration into the industrial space over the last 5.5 years that I've been with Hillphoenix, there's different perspectives depending on who you're talking to. And so from the practitioner standpoint of commercial refrigeration, who have done mostly synthetic refrigerations, what they see is the design of a CO2 system is very similar to that of the synthetics. High pressure liquid is fed to expansion valves that then meter that liquid into the evaporator to vaporize, absorb heat. In the case of CO2, it's always an electronic expansion valve. There's some real beauties associated with an electronic expansion valve. It has a wide range of operation and actually very forgiving to even perhaps flash gas that might be introduced to the entrance of the electronic expansion valve. It's necessary to maintain suction velocities for proper oil return. So oil is miscible with synthetics, it's miscible with CO2. So in order to get that oil that might leave the system and get past the oil separator that's out in the evaporators, to bring that back to the compressors where you want it, you got to maintain velocity. So the gas velocity will bring that oil back with it, right? And that's what these commercial practitioners already know from synthetics. Electric defrost often is utilized for the simplicity of it. But what we see is an interest in alternatives to electric defrost when you start getting into industrial applications. The reporting aspect by the EPA is not necessary when you're applying CO2, so you don't have to report for losses or replacement refrigerant. The way I like to say it is in atmospheric air, as we inhale it, us living beings, when we exhale 100 times more CO2 than we had inhaled. So the EPA is not after any of us for what it is that God designed in us naturally in our breath. So I hope it never comes to that with CO2 refrigeration. Smaller refrigerant lines. I had an application of a customer that had a very large 507 system they were putting in a state up in the Northeast. And it wasn't actually completely installed, but he was kicking himself because he put a 507 system in, and for the particular application, we asked him what kind of suction line you had. He had a 14-inch suction line. Quick calculation, what would have been in CO2? 4-inch suction line. The pressures associated with CO2 introduce the necessity of a new type of copper. It's actually a copper iron alloy. The ASTM number of it is C194. The trade number, name, depending on the manufacturer, would be either XHP or K65. And that would have like a 130 bar design pressure for that copper iron alloy. And then pressure measured in bar. If all your life you ever talked in PSI for pressure, now you got to learn a new language. So what is bar? Okay, so it could be what the ballerina holds in practice, or it could be what the legal attorney fears in having to take the test to get a job. Or it could be like one too many that I hit in college. But in the case of refrigeration and PSI, it's just a different way of measuring your pressure. 1 bar equals 1 atmospheric pressure, so it really simplifies it. So you need to be able to understand and adapt to that. Well, what is the perspectives for the industrial? A lot of what happens in industrial and ammonia applications is the focus on oil. But the oil management of a CO2 system is very, very easy. There's low oil charges, there are very infrequent oil changes, there's no external oil coolers, there's no oil pots that you have to draw from because of the miscibility of it. Pumped over feed, very rare in CO2. The purges and dehydrators, you're not going to see it. It's always at a positive pressure. Hot gas defrost, yeah, that's required, but there's some trade-offs associated with hot gas defrost into an evaporator that might drive the design pressure rating of that evaporator. Inexperience with copper. We know that ammonia and copper are not compatible, but if there's applications that might say, hey, copper could be suitable for that particular project, then that industrial contractor might not have experience with that, and that could be some challenges. But there's no PSM or RMP regulatory requirements. Smaller refrigerant lines, as we had mentioned, high heat recovery or heating potential off the discharge gas of the CO2 system. Minimal maintenance required by comparison to an ammonia. And then oftentimes the ammonia contractors, technicians might be skeptical of something so new and so different. So there's a learning curve associated with that. So where do we apply it? Well, this is a very common application, is in cold storage warehouses. And in that, if you got the majority of the facility is coolers and freezers, and then a dock with a lower roof on it, you might be able to set up some packages on top of that dock level along with the gas cooler, and go to a distributed type arrangement with pipes coming out of that CO2 rack in the house out to those evaporators, either penthouse or hanging air units, or hanging air units in the dock as well. Right? So defrost, a variety, hot gas, electric defrost, warm glycol, penthouse, warm, and all of this is all natural CO2 refrigeration. Right? what we're seeing is a growing interest in applying CO2 in food processing. This is a particular food processor that we served in Pennsylvania. It's a meat processor, a turkey processor. It was 2 CO2 racks in side-by-side houses and put together to form what we call a mechanical room or a machine center, right? And 450 tons of freezing, cooling, processing, hygienic air units with sequential defrost, penthouses, hanging air units, hot gas defrost, loop piping, chilled water for brine tanks, hot water heat recovery, underfloor heat, just about everything you can think of that you otherwise would do in an ammonia system, you can do with CO2. What about system maintenance during power outage? Oftentimes customers might ask about this, and they may move forward with adding an HFC type condensing unit with a heat exchanger, essentially to maintain pressure, connect that to a generator and turn that on when power goes out, just to maintain pressure in the system so you don't blow off any CO2. A lot of concerns associated with that. Do you have enough fuel for your generator? Have you run this through its cycles every 6 months, even if you haven't had power outage, to make sure it's going to be available? Well, I'm happy to introduce an innovation of Hill Phoenix's today. It's what we call the ECU, or Emergency Cooling Unit. It uses the CO2 off of the rack. It takes the side stream off the top of the receiver, feeds that through a compressor, uses the natural convection of the gas cooler to condense down and through and around the high pressure valve, and then back to the receiver. It is either factory installed on the rack, or it's field retrofittable, either indoor or outdoor in a weatherproof enclosure. It can be powered by a generator, or we can power it on the rack with battery sets in increments of 6 hours. How long is your power outage? 6 hours, 12 hours, 18 hours? We'll set you up and just let this thing run and satisfy the system pressure during a power outage. What's the future of CO2 in the industrial market? Right. When we looked at that chart that showed the growth of the transcritical systems, and it started peaking in 2015, 2016, and many customers were adopting that. That's mostly for the commercial market. In the industrial market, I think we're crossing that threshold right now. We've seen the discussions and presentations and applications of CO2 in industrial space for the last 4 or 5 years. It's really coming on strong right now. And so what is the requirement by the market is to provide a safe record of operation in these higher pressures of CO2. Manufacturing larger components, larger compressors, larger valves, larger vessels, larger control systems that can manage larger capacity systems. The technology innovations, like I had mentioned, that ECU unit that's using the system's refrigerant basically to maintain the pressure during an outage. The paths to market are constantly changing and growing. As we look at the market that we serve and more inquiries are surfacing, we realized that we needed to change our approach to market. And so now we have hired on some manufacturers reps. So I rep up in the Northwest, Cool Refrigeration handling the East Coast for us, and then Check Sales handling some states in the upper Midwest. If you have an interest in representing the Hill Phoenix product as a manufacturer rep, please come talk to us. And then lastly, one of the things that we definitely want to maintain in going into the future and riding on that 2,000 unit installation that we've experienced over the last 18 years is to maintain the product reliability that our customers depend on. If you don't have reliability, you don't have anything. I mean, you can use a wide variety of materials to build these systems. We're building 90 bar systems with all stainless for certain customers, and then we're building other systems that don't rate at 90 bar completely, but they're out there and they're running, and they have been running for a good 10 years, and we expect another 10, 15, 20, 25 years of life out of them. So with that, I thank you all for your time.